Hi, I'm talking about solar science today, and this is a new lightning lesson for 2022 and 23. And this is a great lesson for grades K through 5, and it'll run about 45 minutes, maybe a little more, depending on how much the kids get into it. But it's basically a lesson that talks about the sun and some facts about the sun and how the heat from the sun interacts with different surfaces around us. This lesson was taken from Picture Perfect STEM, lessons from K to 2, and Carol Shear adapted it to be a lightning lesson. So, as usual, let me go through the kit and so you can see what will be available to you. There will be directions on how to conduct the solar science lesson. And there will be a book also. You can get your own book about the sun that you're comfortable talking about. We actually don't read this for the class, but we do refer to it and talk about the different facts of the sun. Like, for instance, the surface temperature of the sun is 10,000 degrees Fahrenheit, and how old the sun is, and things like that. And we have an infrared laser thermometer. We have 3 of these in the kit. And I will show you outside what we do with this thermometer. But it looks like this. And it basically, if you point it at something, and you don't point it at someone, just something, you can easily, to get the temperature of, for instance, the wall is 77 degrees. And so I'll show you what we'll be doing with those outside. Now, just adults use these thermometers, and so you would use one, and perhaps a teacher, maybe an assistant in the classroom. And before you actually go to the school to do solar science, you would set up with the teacher that you'll be taking the class outside soon after you begin your introduction. As usual, you do your PPLD introduction, and then you would talk about the sun, and then take the classes outside. Preferably split into 3 groups so that one adult would take one group. And you could go around either predetermined areas of the school grounds and like grass and asphalt, maybe the wood chips on a playground, just different things you could decide beforehand what you're going to measure the temperature of. Anyway, back to the kit. There's tape. And there is bags of recycled materials. Haven't gotten to that yet, but there are pre-ready sets of bags here. And to get the kit ready, I would need to know how many students you'll be seeing. And then we also have clipboards with a form here that you'll take outside to fill in the different surface temperatures you're taking. Right, there is a copied couple pages from the STEM book that is sort of some background information that is useful for using laser thermometers and talking about the sun. Okay, so let's pretend I have a group of students with me, and a couple other adults have other groups with them. But we're going to go around, and on the school grounds, we're going to be touching surfaces, and the students are going to be talking about which one they think is cooler. So I'll ask them that, and what they think will be the hottest surface, the coolest surface. And our sun just now went in behind a cloud, but so if the sun is available, you could also measure the same place, grass for instance, in the sun and in the shade. So you could also do that. All right, so I'm going to take the temperature of my wood surface here first. 94 degrees. So I would write down deck, and it's all in the shade, so I'm just going to deal with one temperature, and it was 94 degrees. There's nothing to compare it to at the moment. And then let's see, let's try the grass. 75 degrees. 75 degrees. And I'm going to just try the glass on my table here and ask, let's see, which would be hotter, the glass or the metal? Let's see. 86 degrees for the glass. And let's try the metal. 92 degrees. So let's do that. Metal. 92 degrees. And I've already forgotten. Oh, 89 degrees for the glass. We usually have 3 spots around the school grounds that we've predetermined to go to. And it's always fun to go to the playground. Wood chips on a playground are very hot and should probably not be the surface. But anyway, it's just fun to see what different things, what the heat or the temperature is of different things outside. So after you get your temperatures all written down, you bring all 3 groups of students back together. And you can talk about what each group found was surprising about a temperature or what they expected it to be in terms of how hot it was and what was cool and and things like that. And then you can sort of segue into the question, well, do you ever get hot outside when you play? And would you like a structure sometimes when it's a hot summer day? Well, the Design It Challenge will be to build a structure that would keep someone cool while they were playing, except the structure will hold an ice cube, not a kid. And so they build a structure to keep an ice cube from melting as fast as it would out in the blaring sun. And that's the last challenge. It takes about 15 or 20 minutes. It only takes a couple minutes at the very end to give them the ice cubes and see how their structure does. And so that is solar science. If you have any questions, email me, Betty McDonald, at bmcdonald@ppld.org. Thanks for watching.